Alright, let's look at the homework 4.6-5.1, number 3. Alright, so helium is pumped into a spherical balloon at the constant rate of 4 cubic feet per second. How fast is the radius increasing after 3 minutes? Alright, so let's do that. Alright, so first we have to, since it's a spherical balloon, so the volume of the sphere is, if we remember, V is 4/3 pi r cubed, right? So we can take the derivative, so go ahead and take the derivative with respect to time, so d over dt, right? So derivative of v with respect to t is dv over dt, right? Then 4/3 pi is just a constant, right? So if you take the derivative, r cubed would be 3r squared, but don't forget to multiply by dr over dt, right? So clean up a bit, 3 here on top and 3 cancel out. You have 4 pi r squared dr over dt. Alright, so we have that. Alright, since we're looking for, let's see, how fast is the radius increasing? So we're looking for dr over dt. So I'm going to go ahead and solve for dr over dt. So this is going to be, right, so we can just divide through by 4 pi r squared, right? So you can see that you have, let's see, 1 over 4 pi r squared and dv over dt is equal to dr over dt, right? To make it look better, I'm going to actually move this guy over to the other side. Right, I'm going to just give a little bit of room. Let's see, a little bit of room by moving here. Alright, and just put dr over dt on this side. Right? Alright, so let's try to plug in whatever we have. Let's see, so since, let's see, the helium is pumped into a spherical balloon at the constant rate of 4 cubic feet per second, right? That is dV over dt, right? So we know that this guy right here is 4, right? And do we know R? Right, let's see, we know that it's a radius increasing after 3 minutes, right? So 3 minutes, first of all, is the same thing as 3 times 60, right? So it's a 180 seconds, right? So after 180 seconds, we know that, let's see, the constant rate, the volume is going to be, right, 4 cubic centimeters per second after 180 seconds. So that's going to be 0, right, 4 times 8 is 32, and 4 times 1 is 4, so 720. Right? So when V is equal to 720, which means that the R is going to be 720 is equal to 4/3 pi r cubed, right? So we can divide through by 4/3 pi. We can get, let's see, so it's a 720 divide by 4 pi and times 3 is equal to r cubed, right? Maybe we can simplify this. 4 and let's see, 720. Right, you can squeeze 1 4 in there. 32 and 9. Oh, actually 8. Sorry, 8. So 180. Right. Then so that's going to be, right. So 0. 3 times 8, 24. And 3 times 1 is 540 over pi. Right. Then to find r, we just raise it to the 1/3 power, or taking a cube root. So r is going to be 540 over pi, raise it to the 1/3 power. Right, so finally we found r. So this r right here is 540 over pi to the 1/3 power. Alright, so we can find r. So r is going to be, it's a little bit messy, but you can see that 4 on the bottom, and this is 4, so dv over dt cancel out. So you're gonna get, it's going to be 1 over, right, pi is on the bottom, right, and the r is 540 over pi to the 1/3 power, but you have to square that, so it's going to be 2/3 power. Right, so let's compute that. So we're going to have, let's bring out a calculator here. Right, so it's going to be 1 divided by pi is right here, right, and then multiply by parentheses 540 divided by pi, alright, and parentheses, and then raise it to the 2/3 power. So 2/3 power. Alright, like that. So let's get the value. Alright, so it came out to be 0.1003. Right, so let's type that in here. Right, so let's say round to 4 decimal places. So it's a 0.0103. Right, so let's check that. Right, got that. Alright, then it says that let's say at what time is the radius increasing at the rate of 100 feet per second. Alright, so let's do that. Alright, so in this case we know that let's say the increasing at the rate, so 100 feet per second is a dr over dt. Alright, so this guy is given. right? Then we are trying to find the R, then plug it into V, right? So let's do that. All right, so we're gonna plug in 100 feet per second, so that's this guy. So you have 4 pi r squared, and so it's times 100, and which is equal to, right? We also know dV over dt is 4, right? So 4 and 4 cancel out, so you have 1, right? So you can see that we can solve for r squared by divide through by 100 pi, right? Divide through by 100 pi, you get 1 over 100 pi is equal to r squared, right? Then you can just take the square root, so raise it to the 1/2 power, we get r. So r is going to be 1 over 100 pi to the 1/2 power. Alright, then we need to find V, but the V is just plug it in, right? So it's a 4/3 pi, and R is going to be 1 over 100 pi, raise it to the 1/2 and cube, so it's a 3/2 power, right? Then in order to, so once, so that's the volume when it has dr over dt is equal to 100, right? Then once you have a volume, then we know at what time, right? So each second, it's going to increase 4 feet per second. All you have to do is divide, in order to find the time t, you can just divide the volume by 4, right? So it's going to be divided by 4, so it's going to be 4 cancel out. So you're going to have a pi over 3 times 1 over 100 pi, raise it to the 3/2 power. Again, it looks kind of bad, but we just have to compute that, right? So bring out the calculator, right? So this is going to be pi divided by 3, right? And divided by, right, 100 pi, raise it to the 3/2 power, right? So that's going to be equal to, right? So it's 1.88 to the 10 to the negative 4 power. So this is going to come out to be, this is going to be about 0.00019, right? So let's type it in. 0.00019, right? Check the answer, right? That's that, right? That's it. I hope that this was clear.